Hello and welcome to this Fundamentals of Programming video, and in this video we're going to have a look at relational operators in Java. You're already familiar with relational operators. We definitely have come across them before, we deal with relational operators in our everyday lives. So for example, if I was to ask you the question, is 10 greater than 5? We know that the answer to that is yes, 10 is a value that's greater than 5. Is 10 less than 5? Well, the answer to that is no. Is 10 equal to 5? The answer to that is no. Is 10 not equal to 5? Well, the answer to that is yes. But in programming terms, we don't use yes or no, we use true or false. So wherever we have answered yes to any of those questions, the outcome would be true, and wherever we have answered no to any of those questions, the outcome would be false. So in programming terms, we use true and false rather than yes and no. So we've already covered certain types of operators in Java, the arithmetic operators, the plus, summation, subtraction, minus, multiplication symbol is the asterisk, the divide and the modulus operator, which gives us the remainder of a division operation. We've covered those, but now we need to introduce a whole range of relational operators. So for example, if we wanted to say if x was greater than y, we would use the greater than symbol. And of course, the outcome of a relational operation like that is going to be one of those true or false values. So if we take a variable x and let's say its value is 10, and take a variable y and let's say its value is 5, when we say x greater than y, those values are compared using that relational operator greater than, and the outcome obviously in this case would be true because 10 is a value that is greater than 5. Okay, so we can also do things like check to see if x is less than y. So if x is 10 and y is 5, then we can check to see if x is less than y. And of course, the outcome of that would be 10 less than 5. The outcome of that would be false. We can also check to see if x is equal to y. And in order to do that, we use a special type of operator in Java called the equivalence operator, which is a double equals symbol, not to be confused with the assignment operator, which is a single equals. So we could say x equals y, which is going to check to see if those values are equivalent. And 10 is not the same as 5, so obviously the outcome of that is false. We can also check to see if x is not equal to y, and we have an operator, a relational operator to do that, which is actually the exclamation symbol and the equal symbol. So the two of those symbols together stand for not equal to. So we can check to see if a variable x is not equal to a variable y, and if x is 10 and y is 5, they're not equal to one another. The outcome of that expression then is going to be true because the values are not equal to one another. So what you'll see in all of these cases where a relational operator is used, the outcome of that expression, or the result of that expression, is a true or false value, which is known in programming terms as a Boolean value. It's either one of the other, it's true or false. So on the table here, we've got all of the relational operators at our disposal: less than, greater than, less than or equal to, where we combine either a less than or a greater than symbol with an equals. It's either less than or equal to or greater than or equal to. And we've got equivalence and also the not equal to operator. Each of those operators, when we look at them, they have their direct opposite. So less than, its opposite would be greater than or equal to. Greater than, its opposite would be less than or equal to, and so on and so on. So we can very easily look at one of these relational operators and say, well, what would the opposite of that be? and this table fills out all of the opposite values. Obviously, the equivalents and not equal to are easy ones because they're just the opposite of one another. Okay, so let's write a little test program so we can understand how these relational operators work. So I'm going to introduce an integer variable called x, and I'll give it the value 10. So x is equal to 10 and int y is equal to 5. We'll use the similar values as we've seen in the slides. And the first thing that I want to do is I want to check to see, is x greater than y? How would I do that? Well, I'm just going to actually use a system out for the moment. We're going to change this around in a minute, but I'm just going to say system out, and I'll use a println, and I'll actually print a message on the screen to say x greater than y is equal to, and then what I'm going to do is I'm going to output the result of this expression x greater than y. So in the brackets here, what's going to happen to this part of my system out is that will be evaluated. The piece in the brackets will be evaluated, and because there is a relational operator in this expression, the result of that is going to be a Boolean value, either true or false. Now, what will the outcome be? Well, we know that x has a value 10 and y has a value 5. So effectively what's happening here is that the value 10 will be filled in for x, the value 5 will be filled in for y, and we can see here that yes, 10 is greater than 5. So the Boolean result of that will be true, and we get the value true printed to the screen. Let's put back in x and y, and we'll actually run this and see what the output is. Okay, so we get x greater than y equal to true, because yes, 10 is a value that is greater than y. Okay, so let's actually expand on this, and we'll do the next bit. Let's check to see if x is less than y. Okay, so this is easy because I've just copied down the same print ln statement, and I'm just going to change it around a bit. So I'll change it to x less than y in the message part, in this part, in the string literal part, and then over here in the expression that I want to evaluate, I'll change that greater than symbol to a less than symbol. And let's run that again and see what happens. Okay, so now we get the outcome x less than y. Well, that's clearly false because 10 is not a value that is less than 5. Okay, what else can we check? Well, we can check equivalence, so we can check to see if x is equivalent to y. And again, I'll copy down the system println statement. So this time I'll just change the message to equals equals y. And the part that I want to evaluate, of course, I need to change that. I'm going to change that also to equals equals y. We can run that again to see what happens, and clearly, well, 10 is not a value that's the same as 5, so we get an output of false there for that. And lastly, what I want to check in this little part of my program is x not equal to y? Well, let's check. Again, copy down my system.println. Okay, and I can change the message part here to not equal to, and change the piece that I want to evaluate. Remember, the bit in the brackets is what's going to get evaluated and give us the outcome of this expression. I can change that to not equal to as well. And again, if I run the program, we'll see that x not equal to y gives us an output of true, because yes, 10 is a value that is not equal to 5. Okay, so that's how the relational operators work, and we can test them out in our programs by printing out expressions like this. Okay, so one of the things that we need to be kind of careful of is that we need to just be aware of the difference between the single equals and the double equals, and I've mentioned this already. So double equals is equivalence, that's a relational operator. A single equals is the assignment operator. So it's quite often when you're beginning programming that you get confused with that and you put in a single equals where you really need to put in a double equals, or vice versa. So just keep that in mind. You will probably make those mistakes, but after a while you get used to it. So for example, when we say x is equal to y, that means that x is going to take on the value of y. So if x is 5, for example, and y is 10, then x is going to take on the value of y, and x will end up being 10. Um, if, for example, we say x is equivalent to y, the double equals, well then that checks to see are the two values the same, and of course that's going to give us a Boolean expression, and the outcome of that is going to be false. So one of the other things that we can do is, for example, let's make this a little bit smaller so we can fit some more stuff in here. So what I want to do here is I want to check to see, for example, does y evenly divide x? So does y evenly divide into x? How might I do that? Well, let's copy down my system.out statement here. And what I can do is I can change this around a little bit. So, well, how could I check to see if x is evenly divisible by y? Well, I could use my modulus operator to do that, because that would give me the remainder. If there's a remainder, then it doesn't evenly divide, right? So I could say, well, x mod y, what do I want to check? Well, if x mod y is equivalent to 0, in other words, there's no remainder. If the mod operation ends up in a value that's equal to 0, well then what's going to happen is it's going to output a true or false value, whether the modulus is equal to 0 or not, and I'll be able to check to see if x is evenly divisible by y. So let's see, I'll put a little is here just to show you this. So if we run the program, you can see that we get the output down here. X mod y equivalent to 0 is true. So in other words, x is evenly divisible by y, and it is indeed, because x is 10 and y is 5. Okay, what else can I check? For example, I could check to see if x is an odd number. So I can check to see if x is an odd number. So is x an odd number? Okay, how would I do that? Well, I can write a system out here, and I can say, is x an odd number? Well, if I take x and I use my modulus operator and I use the modulus of 2, so I divide x by 2, so 2 is an even number, so if I divide x by 2 and I don't get a remainder, or I do get a remainder, then I'll be able to tell whether it's an even or an odd number. So I want to check to see if it's odd. So if it's an odd number, I should get a result that's not equal to 0. In other words, I should get some kind of remainder. So if x is x mod 2, if that gives us a value that is not equal to 0, then the outcome of this will be true and x will be an odd number. Okay, let's check this out. So I'll copy that into where I'm evaluating the expression, and let's check to see, well, what value does x have? So x is 10 at the moment, so is 10 an odd number? Well, we know that 10 isn't an odd number, don't we? So of course x mod 2 not equal to 0, well, 10 mod 2 won't give a remainder, so the remainder will be 0. So when we say not equal to 0, that gives us an outcome of false. What about if I just went up and changed x to an odd number, just to check this out? So let's set x equal to 7, for example. We know that 7 is an odd number. So when I run the program again, you'll see now the output is true, because 7 is indeed an odd number. Okay, I'm going to change x back to 10 for the moment, and x an odd number. What about if I wanted to check to see if it was an even number? Well, that's easy enough to do, because I can copy all of this down and I can say, is x an even number? So if x is an even number, then the remainder is going to be equivalent to 0. And I need to change it over here as well, equivalent to 0 in the expression that I want to evaluate. So I can easily check to see if x is an even number by doing this, and then the outcome will be true or false, and we'll see if x is an even number. So I'm going to save that and run it, and you'll see over here in the output, well, this one here was to check to see if x was odd. So x is 10, so it's not an odd number. The outcome is false. But is it an even number? This one here was to check to see if it's an even number. And the outcome is true, because 10 is an even number. Okay. So the last little thing that I want to do here is show you that we have a special type of variable, a special data type in Java for dealing with these true or false values, and that is the Boolean data type. So it's all very well in being able to print out the result of these Boolean expressions, but if we want to do anything with Boolean expressions, then we're going to have to be able to store the result of those expressions somewhere. Can't just keep on printing them to the screen all the time. So what I can do is I can introduce a Boolean variable, and in Java the data type that we use is Boolean. So I can declare a Boolean variable, and I'm going to call my Boolean variable b, for example. So that's how I declare a Boolean variable, and this Boolean variable will only take a value of true or false. So Boolean variables can only be true or false. So I can use this Boolean variable. So rather than printing out the evaluation of an expression like this in a system.out statement, what I can do is I can use my Boolean variable, and I can store the result of that relation Boolean expression in my variable. So for example, I could say b is equal to single equal, so b is being assigned the value of x greater than y. Okay, so x greater than y will be evaluated, and it will be true or false, and that true or false value then will be assigned to my Boolean variable b. So I could do this in all of my examples here, and I'm going to reuse the same Boolean variable b in each case. If I wanted to store all the values separately, of course I'd need separate Boolean variables, but I'm just going to reuse the same Boolean variable over and over again here for these little examples. So I can say b is equal to the result of x greater than y. And instead of printing x greater than y over here in my system out, I can just print b. So I could change that for all of these. I could say b is equal to, and I'm going to copy that and replace that with b. So of course each one of these is a separate expression, like separate statement, so it needs a semicolon. And I can copy all of these into this expression for my Boolean variable b. I don't need two sets of brackets there. So I can do that in every case. I can just assign b equal to whatever Boolean expression that I want, and that Boolean variable will store the answer, and then I can just print it out. So I'm replacing b in all these system out statements, as you can see. When we run the program, of course, we're going to get exactly the same output. It's not going to really, it's not going to change the outcome of the program at all. All that we're doing is just using a Boolean variable to store the result of the expressions that we've been testing out. That's all. and the value then is stored in the Boolean variable, and we print the Boolean variable out. Okay, nearly there. Last one to do here. So I'll just copy that and put B there and put our expression here. Okay, so as you can see, all I've done in every single case is I've taken the expression with the relational operator that we were using and put it, pulled it out of the system out.println statement, and I'm assigning the result of x, for example, greater than y. The result of that is going to be true or false, and that then will be assigned to my Boolean variable b. And then in the system out, rather than printing the evaluation of the expression, I'm just printing out the value stored in my Boolean variable b. So I can save and run this, and you'll see that I get all the same output, except that I'm just storing the result of the relational expression in a Boolean variable. So I can use Boolean variables to store the result of any relational expression, and of course that will store the value of true or false depending on the values that the variables in my expression have. For example, in our case x was 10 and y was 5, but if those values change, then the outcomes of the Boolean expressions will change, and the value that b gets will change as well. So that was a quick look at relational operators, and a very quick look at introducing a new data type into our programs called the Boolean data type that is able to store the result of Boolean expressions. And in the next video, we'll use these to our advantage in writing conditional blocks that will allow our programs to have multiple branches of execution.